let's try to solve another Leetcode problem. 688 knight probability in chessboard. So this is a probability problem. Normally for the probability, we need to know when we need to use like a plus b, or when we need to use a times b. Yeah, because basically for the probability, we're gonna check. So for example, this is a knight. It can move to 8 directions. And for each of the directions, for example, let me use another color, maybe red. Yeah, for each of the directions, if it is at this direction, basically this probability is 1 divided by 8. Yeah. And if we want to know all the probabilities, it means all the directions should plus. So 1 divided by 8 plus 1 divided by 8, how many times? There are 8 directions, so times 8. So the total probability is 1. Yeah. So for this problem, actually we just need to know when we need to use the times, when we need to use multiplication, and when we need to use the plus. If we understand that, the basic knowledge of probability, normally this should be an easier DP problem. Yeah, because for each of the presence, we still need to know the probability. Maybe the moves k equal to 2. This one can move to the next direction. Yeah, let me try to use a better color, maybe blue. Yeah, it can move to a next presence. So for example, it can move to the next presence. So from here, the probability is 1 divided by 8. And when it moves to there, so for the current step, it is 1 divided by 8. But accumulated with the previous step, it should be times 1 divided by 8. Yeah. So it would be like this. It always depended on the k. So k is how many moves. Yeah. Now let's get started for the problem. As there are 8 directions, so we're gonna prepare a directions array. So inside of the directions array, there will be 2 cards. So one is 1, 2, another is 2, 1. So this means from the beginning, it can move like 1 row, 2 column, 1 column, 2 rows, or it can move 2 column, 1 rows. So for example, this is 2 column, 1 rows. Yeah, so there are 8 directions. Now let me just copy it. Yeah, so here I need 4, and for this 2, 1, I also need 4 because I need 8 directions. Let me just copy that. Now I need to change it to 4 directions. So this is 1, 2, this should be -2, and this should be -1, 2, -1, -2, and this is 2, 1, it'll be 2, -1. So this should be -2, 1, and -2, -1. Yeah. So this, I think this way you're gonna find the 8 directions quickly. You don't need to code 1 by 1. You just need to prepare 1, 2, and 2, 1, and prepare the 4 directions. So this is also like a probability. You just need to enumerate all the probabilities. Yeah. So our direction array is finished. Now we can start the DFS. So I'm gonna prepare a cache because I'm gonna use the DFS. So inside of the DFS, basically I need a row and column, and I also need moves because I need to decide how many moves. Currently, let me give a pass and let me call the DFS function. So it's gonna be row on column, and for the moves, it will be starting from 0. Now I will start the DFS. So I will check the edge cases. So if the moves equal to this k, because we are asked to have k moves, so I'm gonna return 1. Because this is a probability problem. If I go to the final state, it equals to the k state. It means I cannot move, but this is a valid case, so I'm gonna return a 1. If it is invalid, I'm gonna return a 0. So if this moves more than k, so I'm gonna return a 0. Yeah. Now I will check all the different cases, all the 8 directions. So for DRDC, in directions, and I will prepare a row and column. So here I use RW and CL because we have the row and column in order to avoid duplicate variables. I will use RW as row and CL as column. So be R plus DR and C plus DC. Now I need to just check the boundary if it is row more than or equal to 0, less than n, and also for the column. It should be column less than n, so I can start the DFS. Yeah, but I need to accumulate all the probabilities, so the result should be starting from 0, and then I will accumulate all the probabilities DFS with this row and column, and also the moves should +1. But it should be times 1 divided by 8. Yeah, if it was to times 1 divided by 8, so normally for this DFS I need to divide it by 8. Yeah, so this is where I need to use plus and where I need to use multiplication, yeah, to solve the problem. And finally I just needed to return this result. Yeah. Now let me run the testing case to test. It seems okay. Now let me submit it to test if it can pass all the testing cases. Yeah, as you can see, it passed all the testing cases. And let's analyze the time complexity. So this R and C and moves, so it means this R and C is n squared. And how many moves? N squared times k. So it is coming from this DFS here. But let's check this n. N is 25. N squared times k, it is still a small number. But we also need to check that 8 directions, because here we have a for loop, and inside the for loop there are 8 directions. So the total time complexity is, let me calculate. Yeah, so it is n times k times 8. Yeah, and the space complexity is n times k, because we just need to use this case. So that's for today's problem. Thank you for watching. See you next time.